College Algebra 2. This class is College Algebra 1, so I had to backtrack really quickly. I'm just starting my stream. So hopefully everyone had a good weekend. It was productive. You got what you were able to do what you needed to do. Here we go. Let's do that. And let's hit done there. Come on. That's fine. I'm gonna share my screen. This is good. And we'll start the announcements here. Okay. So let me see, as far as announcements go, and I had a whole slew of things I wanted to say. As soon as I start, I blank out. It's 1:11. Oh, there was a question. Yeah, let me hop back in the chat. So in the chat, let me see. One question says, do we need both the access code and the book to access the Pearson lab? Let me see. This is College Algebra 2. So basically to access Pearson, we can walk through it, I guess. Let me just start everything over, close all the tabs. So I'm gonna log into the portal. Let's see, like this, come on. It's probably gonna push. Oh no, it doesn't push, it does that. Okay. So if I log into Blackboard, right? So this is my portal landing page. When I log in, and then we log into our class, which is College Algebra 2 here. Okay. You land here, right? So to access the homework or the assignments, if we open up this first folder, now keep in mind our first assignment was due last night at midnight. So Sunday night at 11:59, every Sunday at 11:59, our assignments are due. And these are basically the Blackboard serves as our main hub for our important links. You got into the Zoom, so that's the first important link. Anything that you see me writing, you're going to see go into that folder number 2. It basically is a link to Box, and so I'll load PDFs and things there. So then our Pearson is in this folder number 3, all assignments. When we click there, you click on the first item, the My Math Lab all assignments, and then you're going to be prompted for payment. So this is how. So there's no course ID, but you have to purchase. You have to purchase the access code. The access code runs right under $120, something like that. But this is College Algebra 2. I will say that if you take any other course that uses Pearson and is using the exact same book, then you don't have to purchase access again. You can use the same login. I know I personally use Pearson. I use this setup for College Algebra 1, but you guys already passed it. I also use for College Algebra 2 and pre-calculus. So that's at least 3 courses where, that one payment will work for at least 3 of the courses that I teach, right? So you click on that first link for My Math Lab all assignments. You just follow the prompts, make a payment. If you need like more time to make a payment, there should be an option to get like 14 days temporary access. You want to go ahead and get started on your assignment so they're not piling up. Also, with all of our assignments, we get unlimited attempts. Our weekly homework and quizzes are due Sunday nights at 11:59 p.m. But we get unlimited attempts at all assignments, and you can work on any assignment past the due date. So even though week 1's assignment was due last night, you can work on it all the way up until the very end of the semester with only a 10% late penalty. So if you want an A- on any assignment all the way up until the very end, you would just have to get a perfect score if you're submitting it late. Let me check the chat one more again. Let's see this. Let's see the chat. Leader, I think I got you. Access code. Yeah, so you had to purchase the access code. You don't necessarily need the hard copy book because when you're working through the assignments in Pearson, it comes with the digital copy of the book. So once you purchase the access to Pearson, it comes with the e-textbook. And it's the exact same thing as the hard copy book, it's just digital, but it has all the same information. Let's see, let's minimize this. No, there was more in the chat. Matthew, is he in the? Okay, I'll get him. And also if anybody knows who Luke Hayes is, just let him know. He just needs to update his screen name or identify himself in some way. That's the only reason I hadn't let him in. I let him in for a hot second, and I'll let in Mr. Matthew. Let's see. Yeah. So if you made it into my Zoom and I didn't like single you out or anything, then that means you got attendance credit. And again, just as a friendly reminder, we are doing remote asynchronous. Let me see, he has two. Let me let him in again because I know his audio wasn't working last time. Okay, so Mr. Hayes, I did let you in. You just need to identify yourself. I don't know your student name, right? So right now you don't have attendance credit.
Yeah, I'm Luke Hayes.
Okay, hang on, because I didn't see. Are you in a different time?
Nah, I logged in at about like 12:56.
No, but what I'm saying is, I'm not seeing you on my roster. Yeah, I don't see you on my roster. So you might want to contact registrar and make sure that like everything is good. Like you might want to do that ASAP because I just don't see you on my roster unless you're scheduled for another time. And all of these presentations are like streamed to my YouTube, so you can always like. Okay, I think you got it. So, as long as everything is chill, I'll let you stay for right now. Yeah, it's fine for right now. Let me see. I'm trying to think if there's anything else. Check the chat one more time. Chat looks good. Okay. Yeah. You don't have to. Again, that's why I was like, I encourage you to either log in with your Morehouse. Let me see. Yeah. So again, the way I take attendance, I let everybody in one by one. So you're automatically getting attendance. Once you make it into the Zoom session, then that means you've gotten attendance credit. Again, we are doing remote asynchronous. You're not obligated to stay. Only thing I require on your end is just get your daily attendance credit. These sessions are streamed to my YouTube, so everything is there. And so basically, what I typically do, like during any given day, I'll usually really class time is set up for a Q&A or a study session, right? So like for instance, today I was like, well, if there aren't specific questions, what I'll do is I'll just take some time to go through as much of the lecture, the same recording that's on YouTube. I was just going to do it live and do as much of it live as I can. Or we can work through some of the homework, but that's upon request. And I just go through the lecture just to kind of fill the dead air. But if you guys want to go through the homework, we can. It just has to be requested. Let me see. Let's try this again. Come on, there we go. So with that, let's take a moment. Okay. Let's try this one more time. There we go. So let's take some time and we can at least, you may or may not have watched my lectures. Again, I'm going to do as much as I can right now, but again, the same presentation I'm going to do now is on my YouTube. I would encourage you to watch it. I want to say I made the student notes available, but the instructor notes are going to have a little bit more information. All right. If you ever need a copy of that, just let me know and I'll make sure that you get a copy. And so we're going to start off with section 1.7 inverse function. So this is College Algebra 2, right? So I know in College Algebra 1, we entered at 1.6 and we typically don't talk about this. So inverse functions, some objectives here. We like to define an inverse function, find the inverse function, use inverse functions to find the range of a function, and apply inverse functions in the real world. So I did have a student in my earlier class that he had questions about his quiz. We were able to pull it up successfully during class and get to the bottom of where we were going wrong with that question. So, if you have questions about homework or quizzes, this is the best time to talk about it. Else, And also, as you're making your way through the homework, make use of the Ask My Instructor tool. Let us send me a screenshot of your question. And I know I've already done one video response, so that's why you want to have your notifications turned on. Subscribe to my YouTube channel, have your notifications turned on. So as I load questions, as long as you're aware, the main thing is just awareness. We'll go forward from there. So what do we mean by one-to-one function? A function is called one-to-one if every y value in the range corresponds to only one x value in the domain. So basically, every y corresponds to exactly one x. We don't have the case where one y corresponds to more than one x. right? An example of something that is not one-to-one is a parabola. Even though a parabola is a function, is not one-to-one because you can find a y that corresponds to two x's, right? So like if you have y equals x squared, when x is like 2 and -2, you have two different y's that correspond to two different x's that correspond to the same y. So that's an example of something that's not one-to-one, i.e., it's an example of something that fails the horizontal line test, which means it does not have an inverse, right? So a one-to-one function, each y in the range corresponds to only one x value in the domain. So every y corresponds to exactly one x. Here's an example of one y corresponding to more than one x, right? So we have this y value, but we have two different x values that map to it. This is like if we had y equals x squared, and then we have x equals 2 and x equals -2. Because when you square both of those, they go to the same y. So that's an example of something that's not one-to-one. This one is not a function because you have one x that corresponds to two different y's. So if we were to plot these ordered pairs, this would be like one point on top of the other, and this is an example of something that would fail the vertical line test. This thing here, where you have one x going to two different y's, I'll call that a split. Whenever we have a split, it's not a function, all right? In the previous example, I call this a merge. This is called a correspondence diagram, what we're looking at here. When two different x's merge into the same y, that's an example of something that's not one-to-one. In other words, it does not have an inverse. So this, even though this is a function, it doesn't have an inverse. This one is not a function because this is a split. Okay, and it's a little bit, it's very subtle, and hopefully, we were able to get to the bottom of that. Let's keep looking at some other examples. So we've introduced this idea of one-to-one. That means that every y corresponds to exactly one x. In a graphical sense, if you're looking at a graph and you want to determine whether a graph is one-to-one, you want to see, you ask yourself, does it pass the horizontal line test, right? A function that's one-to-one, no matter where you draw a horizontal line, it touches it once. If you draw a horizontal line and it could touch it more than once, then that means that that graph is not one-to-one, which means that every y does not correspond to exactly one x, which means the function does not have an inverse, or the graph does not have an inverse. So using the horizontal line test, determine which of the following functions are one-to-one, right? I'm just going to kind of talk through these just for the sake of time. Can anybody tell me what kind of graph this is going to be? What's the highest exponent on any variable?
1.
1, right? So if the highest exponent is a 1, what should be the shape of the graph? If the highest exponent is 1, the shape is going to be a line, right? So this is in the form y equals mx plus b, right? Where our b, the b is our y-intercept. So it crosses the y-axis at 5, it has a slope of 2. So if we have a line, is this an example of something that would pass or fail the horizontal line test? So passing the horizontal line test means no matter where we draw a horizontal line, it only touches the graph once. So if we have a line like this, would this pass or fail the horizontal line test? This will pass, right? No matter where we draw a horizontal line, it's going to touch it once. Can anybody tell me the basic shape of part B? Or in other words, what's the highest exponent on any variable?
That's a square, so shouldn't that be a parabola?
So that's a parabola, right? If we have a parabola, is this an example of something that would pass or fail the horizontal line test?
That'll fail.
That'll fail because you can draw a horizontal line and it'll touch it more than once. So this one, even though it's a function, is not one-to-one. All right, can you tell me the shape of this one?
That's gonna be that whatchamacallit thing. It's like an S, like a unstuck S.
Almost. It's like half of a sideways S, right? So the way I remember the square root to me is the top half of a sideways parabola, right? So if we think about a sideways parabola going off to the right like that, and we only consider the top half, that's the graph of square root function. So if the square root is the top half of a sideways parabola, is this an example of something that would pass or fail the horizontal line test?
Pass.
It would pass, right? It gets a little bit sketchy over here, but you have to know that it's always inclining. You know, a lot of this is visual, and you know, you do have to kind of use your imagination, but you have to understand that that sideways parabola is going to always be increasing. It's never going to flatten out. Right. So the first one we said was a diagonal line. Notice, no matter where we draw a horizontal line, it touches the graph once. So no horizontal line intersects the graph more than once. So therefore, the function is 1-to-1. That was part A. Part B, we said fails, right? So it's a parabola. We can draw a horizontal line that'll touch it more than once. And part C was the top half of a sideways parabola. We said that one passes, all right? No matter where we draw a horizontal line, it touches the graph once. Okay. Let me check the chat. Let me take a moment. Okay, I think we do have some questions in the chat. Inverse functions homework. Pearson has been down for a few days on my end. I mean, so I get to think about Pearson being down. That may or may not, that may be the case, but one, it's only a 10% late penalty on like a homework and quiz. So each of those are like 10% of your grade. That's only like a point, maybe. It's very minimal points for the homework and quizzes. So it's not really going to affect your overall grade that much. You can still go ahead and work and like maximize your points there, and you'll be fine. There was a request to go into homework. I mean, we can do that. That's fine with me. I don't mind. Let's see. So I'm gonna just add a page, and I'm gonna hop over to Pearson. So notice I'm in the Blackboard. I'm just gonna click on this all assignments, and this is section 1.7. So this week we're really supposed to be working on 2.5. We'll start 2.5 on Wednesday. But I know that last week was like orientation, so I was like, okay, well, let's take a little bit of time to go through these. I don't know if there's a specific question in the homework. Review and practice. Let's start off with 5, because I think we kind of did a few of these last time. And again, I could jump to a specific one. You just had to bring it to my attention. It says, let's go, command, here it is. That's a little bit better. Okay. So for this function, find the following. We have x cubed plus 2, and then basically we're evaluating. Okay. I think we can do these quickly, actually. So for part A, it's saying when x is -1, right? So if we plug in -1, -1 cubed means -1 times -1 times -1, which is ultimately -1. Plus 2, so 2 minus 1, I think is 1 there, right? So we're gonna hit 1 and go enter. Let's see if I zoom out. Let me just hit next. Where'd it go? Close. Review and practice. Improve score. Continue. Let's try that again. I think whatever option I chose kind of messed it up. Okay, let's try this. So for instance, in part A, if x is -2, we plug in -2. -2 cubed is -2 times -2 times -2, all right? So that's going to be -8 ultimately. -8 minus 6 is -14. See if I do -14. Okay, let me change something. On-screen keyboard. Let me just turn it off right now. So, okay. So for part A, when we plugged in x equals -2, the output was -14. So then if we plug -14 into the inverse, then it's gonna undo whatever we did. So if we started with -2 and we output 14, when we put -14 into the inverse, it undoes it and it takes us back to where we started. So that one should be -2. So no real calculation there. That was more of a concept. The inverse basically undoes our function. And again, with part C, So that open circle just means composition of functions. That means the second function inside the first. So when you say f compose f inverse, they essentially cancel each other out. And that one should be 275. Because if we plug in 275 into the inverse, we're going to get an answer. And then when we take that answer and plug it back into the original, they undo each other. So it takes us back to where we started. Let me check the chat really quickly. Let me see. Yeah, so for Pearson, we do have to purchase access to Pearson. Once upon a time, these materials were included in the tuition. For whatever reason, Morehouse decided to stop that Include Ed program. So you do have to purchase access. It costs just shy of $120. So in this example, we're asked to find f compose g of x and g compose f and determine whether the pair of functions f and g are inverses, right? So to verify that two functions are inverse of each other, when you say f compose g, you should get x. Also, when you do g compose f, you should get x, right? So when we compose these two functions in both directions, in both outcomes, it should be x, right? So let's start by getting a screenshot. And we're working from here. That's fine. This one, hopefully that's big enough. Oh, shoot, did I lose it? Okay, that's okay. This one, no, it's good. All right. Cool. Okay, so here's an example of something where I'm going to be writing, right? Let's see. Come on. There we go. So notice I made sure to include the question ID. All right. This comes from section 1.7, question 23 from the back of the section, right? So we have the two functions and we want to verify whether they are inverses. So first, let's find f of g of x. Now for this first pass, let's do g of x in green. Okay. So then f of g of x, what does this mean? This means f of, what's g of x? So let's do it in green. G of x is x minus 5 over 4, right? So what we're doing, what this means is we're just going to write the function f as we see it, but then we're going to replace all the x's with the green thing. So again, what this means is we write f of x as we see it, but we replace all the x's with the green thing. So we're going to say 4 times x plus 5. But what's the x in this case? The green thing. Notice my use of parentheses, right? So now we want to simplify. So we have a 4 on top cancels the 4 on bottom. So then we're left with what? X minus 5 plus 5. The minus 5 and plus 5, they're opposites, they cancel. And we finish with our desired result. So that's the first one. But again, to verify that they're inverses, we have to reverse the order and we should get the same result. So then this time we're going to say g of f of x. I'm going to use this color. Whatever fuchsia is. I think that's fuchsia. I don't really know. It's close enough. All right? Because when I think f, I always think fuchsia. Okay, so then kind of doing the same thing. G of, now f of x is that 4x plus 5, right? So what this means is we're writing g of x like normal, but we're replacing all the x's there with the fuchsia thing. So then we're going to say x minus 5 over 4. So typically when I'm doing substitutions, I replace my x's with a blank set of parentheses first. And then I plug in, that helps me to keep track of my signs, my negatives and positives, so I'm less likely to make a mistake. So then I plug in my fuchsia thing. All right. So then we can essentially lose the parentheses because there's nothing distributing. And so this plus 5 is going to be canceled by this guy. And then that's going to give us 4x divided by 4. And then the 4 on top cancels the 4 on bottom. And we're left with x, which is what we wanted. Let me be consistent here as well. All right. So we have now verified that when we say f of g of x, we got x. And when we did g of f of x, we got x. So that's how we verify that two functions are inverses of each other. And let's hop back over to Pearson. Simplify your answer. So we got x. And then we got an x here as well. So then the first one, f and g are inverses of each other. Okay, I'm going to the next question. And I want to check the chat again really quickly. Chat looks pretty good. See if anybody, we got a couple of people. Let me get these students out of the waiting room. I don't even know who that is. It kind of looks like One Punch. Hitoma, whatever his name is. Let's see. I got him already. I think he must be in the next class. His name looks familiar. I'm gonna just let him be because I don't see him on my roster. Okay, don't worry about it. Okay. So we have this f of x. What is g compose f, right? So that open circle again, it means the second function inside the first function. So if we put if we do the second function inside the first, we're going to have 1 divided by 1 over x. So then if you do keep, change, flip, if I need to write this one out, let me know. But it should be here, right? Basically that 1 over x goes into the denominator. So when you have a fraction divided by another fraction, you do keep, change, flip, where we flip the second one. And then ultimately you'll get here. And because they're the same, we should get the same result, right? Nothing has changed. So then are these inverses? We would say yes. If I need to show those details, just let me know. I think you can unmute yourself. Let me see.
Could you show me those?
Okay, we can go back. What was this? That was 8. We skipped some questions. Are we missing something? I must be clicking on something incorrectly. Why is it only giving us partial credit? Okay, let's do this one. All right. So we're gonna go from here. We know what what we're looking for there. So we'll just work with that. Okay. Let's add another page. That's good. Okay. So like the details, right? The things that so basically it asks us first we had to find f compose g of x, right? What does this mean? This means the second function inside the first function. So it means f of g of x, second function inside the first function. So then this means, in this case, f of, now I'm going to do g of x in green. So f of -2 over x, right? So then what we're going to do is write f of x like normal, but replace all the x's with the green thing. So it's going to be -2 over x. X in this case is going to be -2 over x, right? So off the rip, we got a double negative on top, cancels the negative on bottom. And then this is basically one fraction divided by another fraction. So then we can use keep, change, flip. When you have one fraction divided by another fraction, you can do keep. We change division to multiplication, and we flip the second fraction. So keep, change, flip. When we say one fraction divided by another, we do keep, change, flip, right? So then if we're going to do keep, change, flip here, it's going to become 2 times x over 2. You have a 2 on top, it's going to cancel the 2 on bottom. And we're left with our desired result of x, all right? So then we did F compose G. Now we need to do G compose F. We need to do the reverse order. It doesn't always work out to be the same, so that's why we do the test. This means the second function inside the first function. Okay. This means G of, now our F of X is what, negative 2 over X. All right. So then we're just going to write G like normal, but replace all the X's with the fuchsia. Okay. And then I think it's a repeat. You know, everything else is, it's the exact same as what we literally just did. So we get the same result. So then that's the argument.
Yeah, that makes sense.
Okay. Let me see. Oh no, we are out of time. Let's get one more question in. Let's do one more. Now I don't know why that's giving us partial credit. Let's just go ahead and submit this one real quick. See if we can get full credit. Unless we're missing something. Okay.
It's giving partial credit because it's late.
Oh, that's what it is. Okay. All right. That makes sense. Okay. Because that was driving me nuts. I was like, I know these are right. That's fine. Save the best score. We still want a higher score, even though I'm not getting any points for this. Okay. The graph of a one-to-one function is shown to the right. So that means it passes the horizontal line test. Draw the graph of the inverse, right? Let's see. So when we have a function in a graphical sense, to get the inverse, you really what we're doing, we're rotating along that diagonal line y equals x. If you had a set of ordered pairs like the x comma y's, to get the inverse, you just switch the x and the y's, right? So if you just reverse the columns and plot those points, that's another way to do it. So this one, notice, it starts off close to the negative x, and then it finishes in what, quadrant 4? So then if we rotate about the diagonal y equals x, we should start close to the negative y and finish in quadrant 2. Which one of these does that? In the red, I think that's C. I think C is the only one that's behaving properly. Like they should cross along the diagonal, so I'm going to go with C. So again, in a graphical sense, we're rotating about the diagonal. And it does kind of take a little bit of imagination. I see the time. Let's try to get one more in there. Let's try to get one more. Graph the inverse of the one-to-one function. Choose the correct graph that shows the inverse as red. The graph of F is shown as a blue solid curve. So if we rotate it back about the diagonal y equals x, the only one that crosses the diagonal y equals x, it looks like it's A, all right? That's the only one that's like, because they should cross at the diagonal y equals x. None of the others cross like that and behave properly, you know. So let me just go with A. Okay, I think we can get another one in there. The graph of a one-to-one function is shown. Draw the graph of the inverse function, and hit the graph of y equals x is also given. Okay, so here's an example where we're given the ordered pairs, right? So we have like -4, -4, -3, 1, so on and so on. Thank you. So for this one, to me, it would just be easiest to just plot, like if you switch all the x's and y's, so like instead of -3, 1, you're going to plot 1, -3. The next one's going to be 2, 1, and 5, 4. Just switch the x's and the y's and plot those points. To me, that's the easiest way to go about it. And again, typically it's symmetric about the diagonal y equals x. So either of those two ways would work. It should be this one. Okay. All right. I do have it as that time. I have that as 1:45. Are there any other burning questions? So again, the general setup of course of this course, this is typically and for class time, my intent is for class time to be like a study session, because we're 50 minutes, we're just not going to have enough time to really get into the meat and potatoes. So that's why I prepared as much stuff in advance as possible. I do expect that you make your way through my full lectures from a year ago, so you can get a full presentation of each section. Take notes as if you're in class, and then make your way through the assignments on Pearson. Idealistically, you want to come to class with your questions already prepared, but even if you don't, it's okay. That's why I go through whatever material I can go through. I also encourage you all to work together. So I don't know if you have like a group me or something going, but something where you guys are communicating, I think it's a good idea. And also I would encourage you to seek out the tutors, okay? Let me check the chat one more time. The chat looks clear. And I think that student's in the next class. So if there aren't any other burning questions, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. Okay, guys, take care. I'll see you on Wednesday, same time, same place.
Excuse me?
Yes, go ahead.
So I was wondering, since we have to pay for Pearson, do we also have to, I'm sorry if someone already asked this, but do we have to pay for a textbook, I guess, also?
No. Pearson, it comes with the digital textbook. It's basically a copy of your book. So you should still be able to see my screen. Once you purchase access to, I think we talked about how to get to this window. You see on that third item, it says My Math Lab Pearson eText. That's a digital copy of the physical hard copy book. So once you purchase access to this, you have everything you need is here.
Okay. All right, thank you.
Professor, if you don't mind, what is your access code
Yes.
for Pearson?
So, yeah, can you hear me? You should be able to hear me.
Yes.
So you have to purchase the access code. There's no course ID. You might be talking about the course ID.
Yeah, yes, sir.
But
course ID. My bad.
No worries. There is no course ID. You have to access it through Blackboard. I linked it to Blackboard. So, the Blackboard landing page looks like this. You open this folder and you go down to item number 3, all assignments. And then you want to start with item number 1, all assignments. When you click on that, that'll put you into our Pearson account.
Okay, thank you.
Mm-hmm. Any other burning questions? Going once, going twice. Forever hold your peas and rice. Okay, gentlemen. If there aren't any other burning questions, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. Okay, guys, take care. Peace.